Hello, my viewers. My name still remains Ekpenyong with Sunday. I welcome you all to my channel on PU for More Academy. In my previous class, I did justice to the nature or the characterization of polymeric polyol that are chief chemicals in a production of flexible polyethylene foam, irrespective of any production or type you are adopting, whether continuous, semi-continuous, or batch process. Now, if you look at polyol, it's a chief chemicals as far as foaming process is concerned, and they are not of the same characteristics, okay, or property. Let me use the word properties, because there are different kind of these chemicals in the market. The manufacturer who produce polyol at time, they normally send us or send the users a technical data sheet. In that data sheet, there are certain parameters that are well defined by the manufacturer of polymeric polyol that we are going to use for flexible foam production. Those parameters are: one, the hydroxyl value, the residual acid, the water content, the polymer content, and the molecular weight. Now, if you look at the hydroxyl value are key parameters that are used to determine the reactivities of polymeric polyol and that of the molecular weight of that polyol. So in this my presentation today, we shall be looking at the hydroxyl value of polymeric polyol in a foaming process. Okay, this is what we are going to consider today in this my presentation. Now, in the flexible foam production process, there are certain parameters that you need to put into consideration in your formulation before you have the best product. One of it is the hydroxyl value of your polymeric polyol. Hydroxyl value. So what is this hydroxyl value? Hydroxyl value measure, okay, the amount of reactive OH group that are available in the chemical compound, particularly in the polyol. Okay, is very, very essential for the reaction to proceed. If you look at the first reaction of foaming process, which is a polymerization reaction. In that polymerization reaction, it is when the polyol and the TDI react in the presence of thin catalyst, okay, for the formation of urethane bond. Let us do the illustration here. This is what I'm trying to say. One, polymerization. Okay, reaction. In this reaction, we have TDI Okay, this TDI reacting with the polyol. This is a polyol. Okay, so this is alkyl group 1. This is a group 2. Permit me to use that so that I will use it to grade a different at the product side. So this is the OH group. This OH group in question undergo nucleophilic attack with what? The toluene diisocyanide, telling you that this is a nucleophile and this is a electrophile. Looking at this reaction, this polymerization reaction stage, it is being catalyzed by stannous. That is tin. Okay, so this tin catalyst act as Lewis acid. As a Lewis acid, activating this reaction, allowing this cross-linking process to take place for us to have the urethane bond. You know, the Lewis acid, they accept a pair of electrons from another molecule, by so doing form a covalent bond. So when this cross-linked in this reaction, okay, we have a urethane R1 R2. So this is a urethane that is going to, this is R. This is a urethane that is going to form. Okay, so in this OH group, what is simple tell us that increase in this increases the reaction site, making it available, okay, for the reaction to proceed as faster as possible, okay, by making your foam cure faster. That is what OH group does in a polymerization or in the tar forming process. You know, polyol OH group can either be low or can be high. So they are not fixed, even with the molecular weight. So in terms of molecular weight tell us how short and how long is the polymer chain. Okay, so it's all depend on the degree of polymerization. Okay, the production process of this chemical. So if you want a foam property that will be a bit harder and rigid, then you go for OH group within the range of 39 and above. If you want the one that will be firm and flexible, then the reverse is the case. But remember, the reaction is going to slow. That's why most of us, in the real sense of it, the fact that you have a good temperature, you have a well-balanced catalyst and a well-foaming condition, if you touch your foam, the curing process is still slow. So it depends on the types of polyol you are using for that particular reaction. Not that your formulation is not good, because OH group, high OH group make foam cure faster. Okay, so the foam at a shorter time, it will achieve the exact chemical property. So polyol is being produced according to kind of property that is intended application of the foam. If you want your foam to be more extremely flexible, okay, I hereby recommend you for conventional polyol. Conventional polyol have a free solid content that is being that is not modified by a copolymer compared to that of polymeric polyol. So this is how OH value influence the entire mechanical properties of foam, and it is also expressed in a milligram KOH per gram of polyol sample. So this analysis can easily be carried out in your factory premises, setting it up once you have the required reagent and the apparatus. So this will enable you to carry out what we call a confirmatory test to compare with what it is stated in your technical data sheet, and this will enable you to have a consistent foam product irrespective of your temperature. Those one can be handled, you understand. So continue to like my page on your notification bell so that whenever I upload a new video, you'll be notified. Subscription is free. Continue to follow me up. Just like I said, you are going to learn a lot. Thank you. Bye bye.